Okay, good morning. Can you hear me? Thank you for joining me this morning. We don't have many participants, and maybe we can change the time of the session, but let's do it today at 7 a.m. Eastern time. Okay, that means this is the midterm 1 review session. Okay, we do have people joining us, great. And this is part 1, and I will talk about the concept from chapter 1 and a little bit from chapter 2, like section 2.1 and 2.2, which is just a derivative through the limit definition. Okay? And tomorrow you will have the second part with Dr. Bank. Okay? Let's start. If you have any question, you may use the chat box, as always. If you can't attend, if you're not attending at the moment, please use the discussion board. And on the discussion board, you can put any question, because I'm getting like emails if this is okay to put the homework questions on the discussion board. Of course it is, because everybody has slightly different homework questions. That means you can always ask your homework question like on the forum, on the class discussion. Okay? And I will be more than happy to help you, because on the discussion board, it's so nice and easy to type the question. Okay, and then the midweek quiz 3 was quite good. I think I still have like few students I didn't grade because was some issue. But most of you have your grade in the gradebook, and now I see that most of you use the equation editor, which is great, and we will keep working on this, because this week we don't have the midweek quiz, but the next week we will have another one, and you will still be asked to type something. Okay, let's change my screen. Because I will be using a little bit different screen this time, because my other touchscreen laptop it's not working well, which you didn't experience. My other class experienced the pen was like a little bit weird, but I hope the new screen will work well too. Okay, that's what we have. We do have the information. Somebody is asking. Let me minimize this. How can I see the chat box? I can see now. Yes, that's me. Yeah. I will, first of all, the test will be open Thursday, which is June 6th, and will be locked on Monday, June 10th. And you probably remember one of the questions on the midweek quiz. I asked you what is the deadline, but including the time. That means actually it's not midnight, because by midnight I would like you to submit the test. That means test when you were looking at appointments at Examity, it's actually 9 p.m. Because when you start at 9 p.m., you still have time. Okay. That means it's 9 p.m. It has to be open until midnight on Canvas, because you have to finish, but to make an appointment, you have to do by 9 p.m. Okay, that means that's the time, and most of you, I think almost everyone, has an appointment on Examity. That's great. That means you know your day, time, any day, any time between Thursday and Monday. Okay, and we still have homework assignment. Okay, because it's nice, and maybe you can do before the test, because it's just nice few review questions, and you will have some extra points. Okay, also you do have sample tests, which are just like the PDF. You can possibly print the tests, like sample A, B, C, I think I call them, and you can print the test, and maybe you can try to solve it. Like you can mimic the same environment. You can set up a time, like 100 minutes, okay? And you can try to take it and then check against the solution provided. Okay? And then you will see whatever whatever is the number of problems that you solved correctly, that's what probably will happen on the real test, okay, on the actual test. Don't think that it's going to be magic. Yeah, we really have to practice, okay? And I want you to practice, of course. That means do the sample test. Also, you have practice test, which is for extra credit. Yeah, and you can of course take it. I think you can take it few times. And I also open for you the test from last summer, yeah, which was the actual test. You can take it as many times as you want. It's not for extra credit, but for extra practice, which is also good and beneficial to do it. Okay, that means this is, and all of the types of the question that you will see actually are the types of the question that we will ask. Okay? The types, of course, the concept and the style. And I always say, because I also have had a few emails, the type of the question is exactly the same like on the weekly quizzes. Yeah, it's multiple choice, and yeah, you have to pick the answers. And we have to be really careful because multiple choice could be helpful. Like we can take the advantage of this, but sometimes it's tricky. Okay, that means don't just pretend that it's not multiple choice. Try to get your answer and then find the correct option. I'm reading a question on the chat box. On the chat box. If as someone using Examity for the first time, is there anything I should know? You know, the good thing is you may call them, because I will not like check every single account. You may call them and they will check your, like, all of your, if you satisfied all of the requirements. I mean, like the voice, the camera, and probably the speed of the internet. That means you can call them. Probably if you have good settings, you should be fine. You can just log in. They will connect with you and they will check. That means don't worry. You will not start the test before they check everything. Okay? Yeah, that means it's nothing special that you should know. It's just log in properly, okay, and connect with the person, with your proctor. Okay, yeah, let's start. I think I said everything about the practice test. Yeah, do practice. That means start practicing. If you will do every day a little bit, you will see how like more confident you will become. Yeah, I'm solving problems from 6 a.m. to midnight every day for the past many years. Okay, but it's fun. Okay, that means what we have. I'm just thinking if I have to say some. No, I think I said everything. If any question, of course, please use the discussion board, and I will. Yeah. I know that some of you are really active, which I really like it. I really like it. Okay. We will start. That means what we have. I think I have another screen that I can show you. Okay, that's me. You saw that information on the sample test or practice test. Okay, that's mean during the test we can't really use a calculator, notes, any electronics, textbook, any notes, any reference pages, formula pages. Now we have to really know everything. By practicing, I'm sure you can solve 20 problems really fast and correctly. And you will have, normally we have 90 minutes, but since it's like everything is on the computer, and yeah, that means I'm just adding extra 10 minutes. I think it's plenty. 100 minutes is a lot. And you will probably, it will be 20 multiple choice questions. Each of them is worth 5 points, 100 points total. Okay, and you may have your pencil, of course, and the scratch paper. Yeah, you have to have something. I can't imagine solving problems without having a paper. Occasionally, you may see like a little bit more questions, but then will be like so short. Okay, not worth even 5 points. That means sometimes, but normally we try to keep like 20 problems, each of them 5 points. Okay, and again, the type of the questions is exactly the same like on the sample tests and weekly quizzes. Okay, what else I have? Oh, okay, and then we may start the review. You probably saw that list somewhere. Okay, that means one more time, I will talk about chapter 1 and just the beginning of chapter 2. Okay, chapter 1, we did cover the basic concept of calculus, which are the limits. Okay, and we can see we do have a list of limits. I can show you this is 2 pages and the short answers. Okay, just answers. That means what I will do, it's not many, looks like it's a lot. Some of them are maybe time consuming and some of them are not. I will just stop the video for some of our students. Some of them are perfect for the exam type. They are like perfect. They are short. They are like concept, covering the proper concept, and they are really good. Some of them are longer, but they are good for. You will probably realize that if they are too long, they are not. They are excellent for practicing and for mastering the concept, but not for the like the exam type. But if I will be you, I will solve all of them. Okay. Because it's all of the types. That means we will solve some of them. Let's see. That means I can definitely tell you like number 1, number 2, number even 4. Okay, definitely the exam type questions. 7, 8, maybe a little bit challenge, but 8 is also good. And you can see I'm skipping the long one. 10 probably is just like we have to just factor. 11 is a little bit too much because maybe not because it's x to the power of 4. 12 is too much because it's x to the power of 6. Yeah, I mean, I don't want to go all over, but I mean all over them. Yeah, 15, it's really, really good. Okay, let me, because it's all of the types. Most of the question from chapter 1 will be just the limits. Okay, just the limits. You will have a limits and you have to solve. Okay, but what I have to say, most of the limits, yeah, if you will do direct substitution, okay, which means even if we will look at limit number 1, okay, if we will do the direct substitution, substituting instead of h0, 1 plus 0, of course, is 1, square root of 1, 1, 1 minus 1, 0, 0 over 0. Yeah? Because I got one question that, the answer is 0 over 0, like 0, and you're still doing something. No. 0 over 0, of course, is the basic concept of calculus. Yeah? If we will think about a rate of change at that instant, okay? Rate of change of distance over the time. Yeah? Like instantaneous velocity, no rise, no run. Okay, like no distance, no time, but theoretically it is something. We know, I don't want to go deeper, but almost all of them had, yeah, that's the type, 0 over 0. And please remember, 0 over 0 is not 0. First of all, we can't divide by 0. That means 0 in the denominator, that's weird, that's not right. That means we can call this form as like undefined at the moment, okay? But we know that we can do some algebra tricks, some arithmetic tricks, and we can, because it's 0 over 0, which means we can find a common factor. We can find that 0 by rewriting, cancel out, and then use the direct substitution theorem. That means the message is, on the test, you may have the answer 0, but it's really, really rare. Okay? Do not pick answer 0 for this type of limits, which actually are all of them. Okay, 0 is not a good answer. Could be, but what you have to do, you have to make sure that you got rid of the 0 from the denominator. Because if I will do something and if I will end up with the quantity 0, let's say over 5, of course this is 0. 0 on the top is fine. 0 divided by 5 is 0. Yeah, that means if you really simplify it and you remove the 0 from the denominator and still is 0, yes, that's 0, but not 0 over 0. Because some students, they choose all of the answers 0, and that's, of course, wrong, completely wrong. And that means you have to, of course, do the algebra and simplify. But also another thing, and one of the questions I love to ask, okay, like for example, this limit, some of the limits, which now I'm touching chapter 2, some of the limits represents the derivative of the function. And do you remember one session I asked you, like, this limit represents the derivative of the function, and you have to tell me what is the function and at which point, because was derivative at given point. And what do you think, looking at this, the first limit, what, this is definitely the derivative, definition of the derivative. And what do you think, what function and at which point? Can you type the answer for me? This limit, of course, we can still do our algebra, we can multiply by conjugate expression, that's what you actually know how to simplify. But also this limit represents the derivative at the point 1, because we can see, okay? And function is, oh, you don't know? I know that you know. Square root of x. Okay, square root of x. Yeah. This is definitely derivative, limit definition of the function square root of x at the point 1. And now I know what's the derivative of the square root of x. It's just 1 over 2 square root of x, and I can substitute 1 half. And we can even check. The answer is 1 half. Okay? But of course, I know what you will do. For every single root expression, square root expression, you will multiply by the conjugate and simplify. And that's the good way. That's the proper way. But we may use the different concept. The same, this one is perfect. Okay, this limit 19 also represents the derivative of the function. Can you tell me what function? No. Okay, it's definitely at the point 2, and it's 1 over x. The function is 1 over x. I can write here 1 over x, derivative of 1 over x, it's negative 1 over x squared, we know that, section 2.3, and when I substitute 2, for negative 1/4. Okay, but again, it's a concept, yeah, it's concept. If you still prefer to do through the arithmetic, algebra, it's perfectly fine. Okay, that's me. I will not solve many of those. You may ask me which one. That means what I can tell you, I will like the square root expression. That means you will definitely have the limits with the square root expression. Number 19 is also nice because it's like a fraction. You have to simplify if you don't see the concept. That's when we like this. What else? Also, something like this one. This one is actually also the definition of the derivative. Okay. Do you think what's the derivative of what function? Yeah, again, is at 2. And, who can tell me the function? It's x cubed at 2. Thank you. That means function is x cubed. What's the derivative of x cubed? Everybody knows derivative of x cubed. It's 2x squared. But instead of x, yes? Not 2, 3, of course, sorry, thank you. Am I crazy? 3x squared. 3x squared, substituting 2 instead of x, 2 squared is 4, 4 times 3, 12. The answer is 12. Okay, but you may expand this, okay? 2 plus x cubed, expand, you will have 8, you will probably cancel out 8, then you will find common factor x, and you can do the algebra. And what I will suggest? I will suggest to look at the for limit calculation. I do have 2 or 3 practice with Kasia videos and I'm solving lots of limits, I will definitely suggest to watch them and the session from week 1, yeah, because we also solved lots of limits. Okay, that means again, I will definitely ask the limit with square root expression, just fractions, maybe just the like the polynomials, and definitely absolute value. Okay, absolute value we like. I also have a short video just with the absolute value expression. Okay, Tori is asking, wait, how is 1512 again? Okay, because number 15, I'm using the concept. Number 15 represents the derivative of the function x cubed. And derivative of x cubed is 3x squared. And we know that x is 2. Okay, 2 squared, 4. 4 times 3, 12. Okay, or I can copy this question and I can show you how you will probably answer. But let me just, oh yeah, we like limits like this one, yeah, because it's really, okay, Tori, you got it. This limit, it's really, okay, really nice limit because it's the absolute value. Of course, the limit with the trigonometric property, which the trigonometric property is limit sine of x over x as x goes to 0. Okay, do you remember that limit from section 2.4? Sine of x over x, sine of 0 over 0? No? Okay, the limit is 1. Oh, no, we do have to do this, okay? Okay, the limit is 1. But how can we read this limit? This quantity, that x, and that x has to be identical, okay? That means when we have a limit, for example, sine of x minus 2 over x minus 2 as x goes to 2. Oh, my pen is, okay? Then we can see I also have sine of 0 over 0. This will be 1. Okay, that means that's how we can read this property. This quantity, this one, and this one, they have to be identical and they have to be 0. And they are 0 if x is 2. Okay? Okay, that means now we also asking this limit. Do you see the full screen? I'm just checking because I see, of course, some stuff. Yes, okay, good. I don't want to cover why this is not hiding. Okay. And I am recording. Okay, I'm just double checking everything. Okay, that's me, for example, 27. Okay, 27 is a really nice, okay, 27 is a really nice limit, actually, covering that concept. We have limit as x goes to 1, sine of x minus 1 over x squared minus 1. That means at the moment it is sine of 0 over 0. But this quantity, x minus 1 and x squared minus 1, they are not exactly the same. Okay, that means what we have to do, I will try to write, actually, let me remove this. Limit as x goes to 1. Okay, and then we have sine of x minus 1, and probably we have to factor out. Do you know how to factor out x squared minus 1? X squared minus 1? Can somebody? Yes, thank you. I was just waiting for help. X minus 1, x plus 1. And now, can you see how we can use the property? We can say, yes, oh, not this one. Okay, let me change this. Of course, I need the identical. Yeah, I need x minus 1, x minus 1. Okay, that means this blue loop, this is 1. Yeah, we can't, yeah, we can't say they cancel out because we're not canceling, but they as a concept, we can remove them because this is 1. And then what is the final answer? Who can give me the final answer now? The blue loop, yeah, it's 1/2. Thank you. The blue loop is 1, and then x plus 1, 1 plus 1 in the denominator, it's 2. And that means this is really nice concept, and actually really nice limit. And I can tell you this concept, sine of x over x, if x is 0, it's equal to 1, also works for tangent, because tangent has sine of x behind. That means don't use for any other functions like cosine, like for example 25. Can you tell me what is the limit of 25? The question, the limit from 25? I can't write on this because for some reason. Oh no, you see the screen, right? Oh my God, okay. Okay, you see the screen. Okay, that means limit, oh, hang on. 25, Jing Yu said 3 over 8. Tori said 3. Why 3 over 8? Let's do the direct substitution. Cosine of 3 times x. X is 0. 3 times 0 is 0, cosine at 0. That means we do have, I can't write on the top, I can write cosine at 0 and cosine at 0 for that limit. Yes, and what is cosine at 0? Of course it's 1. 1 over 1, it is 1. Okay, that means just this property only works for sine and cosine. Okay, and not for no, for sine and tangent, for sine of x and tangent of x, sine function and tangent function, not for any other, because cosine at 0 actually it's 1, and we don't have problems. Okay, Sanjay, we have to mute you because it's a noise. Okay. Okay, that means you probably know what kind of limits I will ask. Okay, and that's pretty much all of the limits. Let me show you what I have. I have something like, some special product formulas that it's helpful to know, because we have to like expand. Sometimes we have to have expanded form. Sometimes we have to have a product form. Okay, that means make sure that you know them. Okay, now we also have a squeeze theorem that we may use it. Okay, and we remember when we have the relation between 3 functions, f, g, and h, f is the bottom one, we can see the picture, h is the top one, and g is between. Okay, and then if the limit at a for the top function and the upper function, okay, is the same, f of x and h of x has the same limit at a, then the middle function is forced to have the same limit, because it has to go between, okay, at that point. And the typical limit that we will ask will be a limit as x goes to 0, x squared, for example, sine of 1 over x. Okay? That means it's still complicated limit, because what we have at 0, sine of 1 over x is undefined. Okay, and then we have something that is undefined, and x squared at 0 is 0. That we have something, we have 0 times, we don't have value at 0 for the other function, doesn't exist. That means that's also weird. I can't say that something which is undefined at first times 0 is 0. Maybe, but I really have to prove it. That means what I will do, since I see the sine function, I will use the squeeze theorem. Sine of any angle could be squeezed between -1 and 1, right? Because that's the range. Now I will multiply each part by x squared because I would like to create in the middle my function. -1 times x squared is of course negative x squared. +1 times x squared is just x squared. And the middle part is x squared times sine of 1 over x. Okay, and as x is 0, this is 0. As x is 0, the right-hand side is 0. That means my middle function must be 0. Okay, because of the squeeze theorem. So now I'm definitely sure I do have a proof, I do have evidence that this is 0. Okay, you may, this is the nice limit. But of course, asking just the limit, it's a weird question because now you will remember it's 0. We may ask like, what theorem did you use to apply to solve this limit? Oh, yeah, I can just remember the squeeze theorem. Okay, what else we need? Okay, that means please remember, okay, all of the limits. Do not miss any limits from that list, yeah, because half of the test will be that limits. Also, the important concept from chapter 1 was continuity. Okay? Function is continuous function at the point A, if, of course, the point A is in the domain. Then if the point A is in the domain of the function, then we definitely have the value. Value will be defined, f of A. We also have to compute a limit at A because we know that the value and the limit could be different, but we can compute a limit and we assuming that the limit exists. And now this is kind of like a conclusion. If the limit exists and the value exists, we expecting these two quantities to be the same. And like practically, this is the definition. Yeah? That's the same. That's the definition of continuity. We have to compute a limit and the value. Compare them. If they are the same, we have continuous function. And we know continuity is simply, we're drawing something without lifting the pen. Nice and smooth curve. I mean, we may have a sharp function, which is still continuous function. And now I can show you a few questions that are related to the continuity. And we may ask you, okay, something like that. For what value of b is this function continuous everywhere? Okay, that's when we do see quadratic function defined for x less than 1. Quadratic function, parabola, it's definitely continuous function. We see the third degree function defined for x greater than 1. Also nice and smooth curve. All of the polynomials are continuous function. And we see the value exactly at 1 is the value b. That means like just the dot. But what we want all of them to be, connect. Yeah, that we will have, I don't know exactly, but parabola, x squared, and then the value b, and then the cube function. That's what we want, nice and smooth. But of course, the thing is that point, that b. Okay, what value of b will give me continuity? That means what I will do, I will simply use my definition. I want limit, and of course 1. Yeah, the point 1, it's the question mark. When x limit is at 1 from the left-hand side, must be the same like the limit at 1 from the right-hand side. And of course, the value at 1 must be the same. What is the value at 1? Can you tell me the value at 1? Value of this function at 1? Exactly at 1, which part of the function, because we have pieces, piecewise defined function, which pieces are defined at 1? I'm just changing. It's just b. Yeah, you can see at 1, yes, yeah, it's just b. Thank you. Right. Okay, but we have to focus on the limits. That means if we compute one of the limits, I mean, they all have to be the same. Okay, then they will be the same like the value, and yeah, hopefully we can find what is b. Okay, let me write limit as x goes to 1 from the left. And can you tell me which function I will use for the left-hand side and which function I will use for the right-hand side? On the left-hand side, it's, yeah, the first one, x squared plus ax. And on the right-hand side, I will use 2x cubed minus 2ax plus 5. Okay. And I can simply because it's just polynomials, I can substitute 1. 1 squared is 1. And then a times 1, it's a. 1 cube is 1 times 2 is 2. No, I don't like my new pen. Minus 2 times 1, it's 2 times a, and plus 5. Okay, that we have just a really simple equation. Really simple equation. We can solve for a. Solving for a, can you help me? It will be 3a on this side. Oh, why is jumping? And 7, I believe 6. That means what is the a value? Yes, thank you. The a value is 2. Okay, if the a value is 2, do you know the value for b? What do you think? You can almost see right away, no? And luckily the 2 is not an option. Yeah. Okay, I can put this is b. That means we have to, no, not. I wanted to change the color. Okay, so we can see this. Okay, and this, it's the b value. And I hope my first box on the left and the box on the right-hand side, it's the same. What is this value? What is this box equal to? 1 plus a. What is 1 plus a? Oh, we know what is a. It's 3, thank you. Can you check if this box is giving me 3? 2 minus 4 plus 5. Yes, okay. That means what is the value of b? Of course, it's 3. You can see a little bit of here, but we use the concept. Limit is 3. If a is 2, of course, then the right and the left is the same, and that's supposed to be also the b value. Okay, yeah. Limit concept. I mean the continuity concept. Okay, let me show you. I have one more, and I love this question because this one includes lots of stuff. Okay, it's kind of like, yeah, the same thing, but asking for the limit only. But let's see. For what value of the constant c, the function f have a limit as x approaches 2. That means on the left-hand side, at 2, we have the first function, the first part. On the right-hand side, for x is greater than 2, we have the second formula, the second piece. Okay, and we know that the limit exists if both of them, the left and the right-hand side limit, are the same. Yeah, that means the same. If they are the same, we may have continuity. However, this function is not maybe easy for continuity because this function is not defined at 2, the first piece, and the second is not defined at 2. And we don't have this middle part like we had in the previous question. That means probably at 2, we do have a hole. But even if we have a hole at 2, Yeah, let's say this is 2. I can still have my left-hand side limit end up here and something like that. Actually, the other one is the linear function. It's okay. They can meet at this, yeah, at the same level, which means the limit exists. Okay, we don't have continuity, but, and let's see. What we need a limit as x goes to 2 from the left-hand side, and then I will use that formula, sine of c x minus 2 over x minus 2 must be the same. Oh no, my pen is limit as x goes to 2 from the right-hand side, and then I will use, let me maybe remove the picture. Yeah, that we do have, wow, we have 2 nice limits. Okay, we have to compute the limits on the left and on the right-hand side. It's also a good practice for the limit. Which side shall we start? Because for this type, okay, actually I just said, we can't just substitute 2. Yeah, can you see, like, do you remember the previous question? I did substitute 2, and I had nice polynomials, no 0 in the denominator, no problem. I could solve it. This one, when I substitute 2, I have sine of 0 over 0, and this is not identical 0. That means I definitely have to do something. This one, I have 0 over 0. It's not 0, of course. No, that's not really 0. Yeah. That means I really have to do. That means what I will suggest, do not combine them. Yeah. Let's work here, and let's work here. Why is changing the slide? Okay, and then as soon as we have a nice simplified value, then we can solve as an equation. Okay, let's actually start because we talk about this one. Do you know what is the limit of this side? Sine of c times x minus 2 over x minus 2. And x goes to 2, of course. Yeah. We just said that we need identical 0. That means in the denominator, I can't change my colors. In the denominator, I will really like to see a constant c. Can you see this one? C. That means what I will do, I will multiply my denominator by c, but since I am multiplying denominator, I also have to multiply numerator. Because if I will cancel them out, I still have my original expression, but I will not cancel them out. Let me do one thing. Hopefully I will come back to my, oh yes, I have my colors. Okay, and then you can, that means we need this additional c, and now I will loop this. I have sine of c times x minus 2 over c times x minus 2. This limit is 1. And that's my property. Do you remember we have to have identical values, sine of a quantity over the same quantity. And what's left outside the loop is just c. Okay, excellent. That means I have c on the left-hand side. Really nice limit. Okay, my right-hand side. My right-hand side has the absolute value. That means we remember, I can get rid of the absolute value, like I can completely ignore it if the quantity inside is positive. Yeah, like absolute value of 5, it's just 5. Okay, but absolute value of negative 5, it's not negative 5. That means I can't ignore it. I can copy that negative 5, but I have to make it positive. Okay, that means if I will investigate this quantity, because I have quantity 2 minus x inside the absolute value. Do you think this quantity is positive or negative? when x goes to 2 from the right-hand side. What's the number 2 from the right-hand side? Do you think you can tell me the number from any number 2 on the right-hand side? When we have a number line, 2, and the right-hand side. That's the right-hand side. Oh, 4 is far, far, far away, okay? We are in the calculus class. I was thinking about number 2.001. It's good. Yes, actually, it is on the right-hand side. No, it's good. It's good, yeah, but no, do you remember, we are so close, like everything has to be almost, we are almost at 2, but not at 2. Yeah, we know the limit concept, the calculus, the biggest achievement, I think, of the human beings, yeah, beautiful concepts. Okay, that means, no, we are so close. Okay, that means if I will say, if I will have look at the arithmetic, 2 minus 2.01 or even 2 minus 2.001, I will always get tiny number, yeah, almost 0, but always negative. Okay, that means actually the quantity inside is negative. If it's negative, I will solve the limit. I will copy this like it was. I will remove this. Okay, I will copy this like it was, and then the quantity inside was 2 minus x, and I'm making this positive, yeah, because this was negative. Negative and extra negative, you can see this, is giving me positive. Okay, and now I can distribute that negative. Still x minus 2 in the on the top. Negative times 2 is negative 2. Negative times negative x is positive x. And I switch the order. Perfect. No absolute value, identical items 1. That means I'm just have c and 1 on this side. C is 1. Then the limits are the same. And actually the limit is 1. But we don't have to find the value of the limit. We have to find the value of the c, and c end up being the limit on the left. Okay? But I can tell you, I can create like 2 questions, because I can only ask you for this limit, or I can only ask you for this limit. Yeah? But since the limits are relatively easy, we can still create this question. It's a really nice question. Okay? Okay, limits, continuity. Okay, I do have something like this, like the graph, a little bit of the limit, a little bit of like derivatives. That means this is touching also chapter 2, okay? And maybe we can answer really quickly. Looking at this graph, okay, we have, yeah, few problems at 1, at 2, at 4, even at 6, and that's it. That means let's try to answer these questions. Okay, nice practice. Okay, question A. The limit of the function f of x, which is the above function, exists and exists at 2. Okay, okay. Do you think the limit, it's true or false, of course, true or false question. Do you think the limit of this function at 2 exists? Exists. What do you think? 2 is here, and how function behaves on the left and on the right hand side? Because the limit, yeah, if we're talking about the limit, we're looking at the left and the right hand side. It's actually false, right? It is false, because who can tell me what is the limit at 2 of this function? Actually, function is going up. Okay, that means it's simply infinity. Yes, thank you. And infinity means that the limit doesn't exist as a finite number. It's still an answer, but doesn't exist as a finite number. Okay, limit at 4. Do you think the limit at 4 exists? At 4. Yes, yeah, because at 4, I can maybe add a few numbers, 1, 2, 3, 4. Can you tell me what is the limit at 4? The limit at 4 is 3 or 4? It's 3. Really good. Because we are actually looking at that level. Yeah, we're looking what function does. Function on both sides approach that dot, not the solid dot. Solid dot is the value. We're looking for the curve, what curve does. Okay, that's mean this is true. The limit at 6 of the function exists. What do you think? Do we have limit at 6? Yeah. Oh, no, we do have, okay. Probably who answered, oh, Jeb and Tori, probably you answered this question. Okay, the function is differentiable at 6. No, when we have a sharp corners, this is false. We do not have derivatives, okay? But in terms of the limit, function actually meet. Function actually is approaching on this side, and on this side is approaching the same value, let's say 3. That means this is true. Limit exists. Even if we have the sharp corners exist, derivative is undefined. Okay, D. Function has a jump discontinuity at 4. What do you think? Is this the jump discontinuity or different type? Yeah, it's not a jump. It is false. It's actually removable. Yes, thank you, Ronald. Because only one point is removed. Yeah, it's removable. Okay, function has an infinite discontinuity at 2. What do you think? Can you see this? Yeah, of course it's true. Function is continuous at 6. Yeah, at 6, limit exists. No, we may have a limit exist and we may have discontinuity, but even if we have sharp corner, doesn't matter. Function actually, it's continuous, no gaps, no jumps, no asymptotes. Okay, now G, function is differentiable at 4. Do you think we have derivative at 4? We have discontinuity, and as soon as function is discontinuous, no derivative, no tangent line, no slope, no derivative. This is false. Okay, and the last 2 problems are a little bit challenge, I might say, because okay, let's see. They asking for the limit of the derivative. The limit of the derivative f prime of x exists at 4, which asking for the limit of the derivative, they want to know how the derivatives behaves. Derivative, it's simply the slope of the tangent line. That means how the derivative behaves at 4 from the left and from the right hand side. That means, let's see, of course, exactly at 4, we do not have derivative because we don't have a point. I have a point somewhere else, but that's not derivative. That means I can definitely draw a tangent line on the left and on the right hand side. Yeah, and we can see they almost the same. Do you think they have almost the same slope? Do they go in the same direction? The tangent on the left and tangent on the right hand side, they're extremely close to 4. They have the same slope. Of course, just one point is removed. That means this is definitely correct. Since they have the same slope, the same value, the limit is the same, right? Because they asking for this. But what do you think at 6? At 6, at that sharp corner, we don't have derivative, right? But we do have derivative on the left and on the right hand side. I can draw a tangent on this side and I can draw a tangent on this side. Do you think both of them has the same slope? Do they behave the same? They have completely opposite. Oh, I'm sorry. I'm sorry. They have completely opposite slopes. That means this is false. Okay, That's false. Oh, no, no, no. Okay, we're almost done with chapter 1, but let's see what I have. We will skip this graph because it's the, I was going to ask the same question. Yeah, this is important. Yeah, it's also connecting continuity and derivatives. That means please remember, if function is differentiable, always is continuous, always. Okay, if it's not continuous, it's not differentiable. That's true, that's true. Okay, this is false statement. If we have continuity, we may not have derivative. And of course, the sharp corners. The perfect example is absolute value of x. Yeah. Absolute value of x. It's the proof. Make sure, because we may use this as a true and false questions. But just this, yeah, no tricky part. And then, oh yeah, I have just the graphs. We know that. No derivatives, and no derivatives. Okay. And I did copy a few functions, like a basic functions, fundamental functions, or parent function, depends how we call, that they are really helpful to be known right away. Yeah, absolute value of x, x squared, x cubed, 1 over x, square root of x. Let's keep this one for now. Cube root of x, 1 over x squared, x to the power of 2/3, which is like cube root of x squared. Yeah, make sure that you know the shapes, because it's helpful. It's helpful to know. Okay, we will skip this one. Oh, we do also have intermediate value theorem. Yes, you will have this PowerPoint, of course, right away. After this session, I will put the PowerPoint, and I will put the link to the video. Okay. Okay. We also had in chapter 1, section 1.8, intermediate value theorem. Okay. And that's the theorem, and I can show you the question, how we may ask. Okay, suppose that function is continuous function. Of course, if we do not have continuity, nothing works. Continuous function on the closed interval. And let n be any number between f of a and f of b. We can see any number. Yeah, I can. That's all of the numbers. Okay, and we don't want value f of a and value f of b to be the same, because then it's a little bit, they have to be just different. Then there exists a number c between a and b, okay? Then the corresponding value for c is, of course, n. That's what this means, basically. If I have these two dots, the red dots, and if I will connect them anyway, I will connect them like that. And if I will draw any horizontal line, n between f of a and f of b, the intersection will always fall between a and b. Always, yeah? When I draw the line, the intersection with the curve will fall, will give me the corresponding x value between a and b. Okay, nice and easy. But how are we using this? Okay, we may ask this way. Let f be continuous function between 5 and 10. F of 5 is 1, f of 10 is 4. Okay? Which one, only one, of the following statements must be true? That's what I will do. I will draw the scenario. F of 5, let's say this is 5. F of 5 is 1. Okay, my scale is here, but it's okay. That's 1. F of 10, it's 4. Here. Okay. And I know that function is continuous function. I can connect these two dots anyway. Let's say like that. Okay. And now let's read the statements. F of x equals to 3. Yeah, that means the value of the functions equals to 3 for some x's between 5 and 10. That means 3 is actually between, 3 is here, between 1 and 4. If I will draw this line, do you think this intersection, it is between 5 and 10? Yeah, that means this looks like correct. This, looks like a correct statement. But I will double check the rest of them. Yeah, because it's a little bit of, it's like a logic of mathematics for some, even on, let's check. Let me change the function a little bit because, okay, we can, something like that, more variety. Then we can answer the last question. Okay, the value of the function equals to 3 for some numbers between 1 and 4. Oh no, yeah, they messed up that's wrong. Yeah, they messed up the y values. Okay, f of 7 is between 5 and 10. 7 is somewhere here, and I could even not have the intersection. 7 is outside the values. That's wrong, that's wrong. F of 7 for, oh no, they messing up the x values. And this one, the value of the function is 1 if and only if the x is 5. That we can see we do have the value, but if I will draw the whole horizontal line, this is corresponding x value, this is corresponding x value, and this is corresponding x value. That means I have x sub 1, x sub 2, I have multiple x's, then where the value, the horizontal line is 1. That means it's also false. Okay. Of course, the statement A, it's the intermediate value theorem. Yeah, that's how we can test. Okay, I have another one. Shall we maybe solve it? And okay, and that will be, I have this question and one more. Okay, and we will wrap up the session. Okay, according to the intermediate value theorem, in which of the following intervals must the function x cubed minus 3x squared minus 2x plus 3 have the 0? Okay, that means a little bit different way. So this is polynomial third degree, nice and smooth curve. And we want this function to intersect the x-axis, 0. Right? That means something I don't know, but I want this function to intersect, to have the value 0. And now I don't have to find exactly what is the 0, but I have to make sure that this 0 is maybe between -1 and 0. That means maybe between -1 and 0, because that's -1, that's 0. That's maybe, I don't know, I have to check that. Maybe here between 0 and 1, maybe between 1 and 2. Okay, I have to make sure that my intersection, intercept, is in one of this interval. Right? That's how we can check this. This is the nice way to apply the theorem. I know that this function is definitely continuous function. That means I'm able to use the intermediate value theorem. And what I need, let me maybe draw something here. If I will take any, even this, let's say, if I will take the interval -1 and 0, okay, what I would like to expect, I would like to expect the corresponding value at -1 possibly to be below the x-axis, negative, okay, and the corresponding value for 0 possibly positive, above the x-axis. Because if I have one value below, one value above, connecting these points, I have to go through the x-axis. That means this will be the proof that I will intersect the x-axis. That means I will have the 0. Okay, that means what we have to do, we have to take the end points of this interval and check the value, do the arithmetic. And we really want one value to be negative, one value positive, or the other way. Then connecting them, because they are continuous function, we will intersect the x-axis. That means let's check. It's a little bit of arithmetic, but we will do. the first thing is I need the value of the function for -1, and my writing it, and I need the value of the function for 0. Okay, please help me, because it's the arithmetic and it's end of the session. Let's substitute -1. -1 cubed is -1, -1 squared is +1, -1, okay, and this. That means this looks like a value 1. If yes, thank you for doing the arithmetic, because doing arithmetic, it's challenge sometimes, and especially with the nice, easy numbers. Okay, and then at 0, of course, is just 3. Thank you. That's in what we have. We have positive number, positive number. That's not a guarantee. If both of the dots are above the x-axis, I can just connect them without intersecting. That means this is not a guarantee. Okay. Now we need the value at 0, which we have the value at 0, and we need the value at 1. At 0 is 3. Can you help me to get the value at 1? Negative. Oh, it's negative? 1 minus 3 minus 2 plus 3. Wow, great. Because what we, yes, okay, just, that means this number is 3, it's positive, and this one is negative. I can draw this situation. Value at 0, it's 3, and value at 1, it's -1. My scale is off, but I just want to show you. And then connecting these two dots, I am creating a 0. Yeah, that means do you understand the concept? That's the concept. 1 dot above, 1 dot below, and then definitely 0 between. Yeah, the value 0. Okay. Do you know, if I will take a test, I will quickly check the other values. Yeah, especially because the arithmetic, the easy stuff, sometimes other. Oh, my screen. Okay. The value for 1, let's just quickly do. The value for 1, it's negative. What about the value for 2? For 2, it's -5. I believe you. That means, okay, that means that's not the case. Both negative, not good. And can you check the value for 3? Probably it's negative. Oh. If we will put 3, it's -3. I am just believing you. It's also negative. That means both negatives, not good. Why my slides are changing without my control? Okay, but we understand. We need 1 dot above, 1 dot below. Done. Okay. You will get 100% so easily on your test. But I do have, of course, the definition. Yeah, make sure that you know the definition, because we will not ask you to type a solution like I'm asking on the midweek quiz, no, but we may still ask you a question which involves the definition of the derivative, which, for example, oh yeah, we don't really have to look at all of this theoretical part, just the final formula. For example, what question I can ask? Okay, even this one. I'm asking, find the formula for the derivative. I know that you can use the formulas, the power rule, but what I'm saying, if I will ask you to use the definition, okay, that means derivative is defined as a f of x plus h minus f of x over h. And then we will try to evaluate. Yeah, that's what was the question, almost the same question, different function, but the same question, the same concept on the midweek quiz. We will put x plus h, okay, over 1 over x, because it's over h. Yeah? And then I can simplify, multiplying by x plus h and x. Okay. My gosh, the pen, you see I have new pen and it's not working nice. Okay, when I multiply the first fraction by this will be gone, right? Only x will stay. If I multiply the second fraction, x will be gone, then x plus h will stay. And when I multiply denominator, everything stays. Okay, and for example, one more step. I will distribute negative. Remember about this, because that was the mistake on the midweek quiz. A slightly different function, but also with the negative. Okay, and we can cancel out this. And now I can cancel out h. Right, I can cancel out h. And we do have a final answer, -1 on the top, h is 0, x times x is x squared. Okay? I know that you knew it right away, but what is my point? My point is I can ask you like which of the step, like which of this like part of the solution, it's the correct form of the definition of the derivative. And for example, I can type this. I can ask you, is this blue box, this one, part of the definition of the derivative for the function 1 over x? And it is. Okay, or of course I can ask this one. This one actually looks nice. I did skip this. -1 and then x plus h times x. Yeah, h is 0, of course. This is also nice form. That means just make sure that you know the steps, and we may just pick like things like that. Okay, and we will not do this one, but this is supposed to be my last slide. That means let's don't do this one because it's maybe too much, too big numbers. Let's try to answer this one. Do you think you can answer quite quickly that limit? Limit as x goes to 0, 4 plus x cubed minus 64. 64, I can tell you, is 4 cubed. A little bit of hint, over x. Do you think this limit represents the derivative of the function? Derivative at which point? And what is the function? Okay, we can definitely see, yeah, I can rewrite limit as h goes to 0, 4 plus h cubed minus 4 cubed over h. Yeah, it's the derivative of the function at 4, and function is simply x cubed. Okay, we may expand this and simplify, but just in case, make sure that you know how to get through the derivative. Okay, that means what is the derivative of x cubed? We had this today. I promise it's the last question. Oh, what's the derivative of x cubed? Yes, thank you for typing. 3x squared. And now, if x is 4, can you tell me the final answer? Because that will be the answer. 3 times 16. Oh, what is 3 times 16? I know what is 3 times 16 because it's quite a nice number. Lots of factors. 48, thank you. I just was waiting for it. Okay, that means this limit is 48. Okay? That means please make sure that you know these tricks, this concept approach. Okay? Okay, oh, I kept my video on for the entire time. I hope it's okay, because sometimes it's better not to see your instructor. Okay, that means this is that's my last slide. You will have probably my next, oh yes, my next slide is, hang on, but you will have this tomorrow. My next slide is just the formulas, but Dr. Bank, he will run the session for you tomorrow. Okay, and make sure that you know everything from this session and from the Wednesday session. If you really need some help with some additional problems, let me know, and I can always put a quick video solving problems for you. Okay, I can definitely do some, I can solve the question, the limit, anything, whatever you end up with, please ask on the discussion board and I will, it's so easy for me to solve it and make the video. And I can put on a link on the discussion board, okay? Promise that you will do this, ask the question, because I want, and of course, practice a lot. I want you to practice and you will see the test will be so easy. But you have to start now. Print the samples, A, B, C, and D, okay? And don't look at the solution. Try to solve it on your own, yeah? No breaks, no notes, no coffee breaks, no bathroom breaks, no. 100 minutes. Try to solve it and then check against the solution. If it's like, if you manage to solve 50%, that's probably what you will get. That means keep practicing, okay? And then I know that you will be good. Okay, thank you very much for joining me. Maybe I will change the time of the session, okay, because I want more students to attend live, but also watching is also helpful, okay? That we will see in the following weeks, but good luck with your final, okay? Oh, we still are connected. Okay, thank you.